So we are going to do section number 7 of chapter 1, which is going to be about distance and midpoint. We've actually already talked about distance and midpoint, but we're going to be talking about it in 2 dimensions now. So distance and midpoint in 2 dimensions. Alright, so let's just review midpoint in distance in 1 dimension. Well, how do I know how many dimensions I have? Well, it depends upon how many pieces of information you're given for a point. So it's pretty easy, actually. If I'm given 1 piece of information for the point, I'm in 1 dimension. If I'm given 2 pieces of information for the point, well, then I'm in 2 dimensions. And if I have 3, well, then 3 dimensions, and so on and so forth. So if I give you find the midpoint in distance, between point A, which I'll say is -5, and point B, which I'll say is 13, well, how many pieces of information do I have for point A? 1. -5. How many pieces of information do I have for point B? 1. So I'm in 1 dimension. So our formula for midpoint, now I gave you one that's a little bit different than your book. It ultimately comes down to just subtracting, but I gave you it this way so that when we do 2 dimensions, it actually is very similar. So that is, oh, that's not midpoint, that's distance, sorry. And our midpoint formula is x1 plus x2 divided by 2. So, we just put in the numbers into our formula. Now again, the distance you're just going to end up subtracting in the end, and it's going to end up being positive. It doesn't make sense to have a negative distance. We are not going backwards in time. So we are going to put in our numbers. I just do x1, x2. So -5 minus 13. We'll square it and take the square root. But ultimately, you really don't even need to do the square root or squared thing. You just subtract those, and you will get your distance. So -5 minus 13 is -18 squared. And then a square root undoes a squared. So I just need to make sure I make that positive in the end. So 18. Okay? So that's the distance between those 2 points. And when I show you the 2D formula, you'll see why I gave you this overly complicated one for 1 dimension. Midpoint in 1 dimension, I'm going to add those two. It's basically an average. I do need to keep the sign of that -5 though. So -5 plus 13, then I divide by 2, and then I have 8. Right? Is that 8? Yeah. Yes, and then 4. So that's the midpoint. That's the middle. Remember, midpoint, middle. It divides the segment into 2 pieces, and distance is the length. So distance, midpoint. Okay? So that's in 1 dimension. We've already talked about that. You've already been quizzed on that. So now let's get to 2 dimensions. I'll let you finish up writing that. I see some people are still writing. So I'll doodle someone's face.
Me? No.
Daniel.
Oh,
Oh,
he's
no.
doing
Yeah.
Zoe. Oh, no, it's Zoe.
This is Victoria. Okay, anyways, going on. 2 dimensions, same formulas. Well, not the same exact formulas. Distance. We have 2 pieces of information in 2 dimensions. So we're going to have x1 minus x2 squared. So see, just real quick look. We start the same way as in 1 dimension, but now we just add 1 more piece to it. y1 minus y2 squared. That will give us our distance.
Seems simple enough.
And then our midpoint is an ordered pair, so we're just going to have some parentheses. It's going to start the same way as in 1 dimension. x1 plus x2 divided by 2. y1 plus y2 divided by 2. So I just have an extra piece of information because I'm in 2 dimensions. Does it make sense what I'm trying to say?
No.
And guess what? If I was in 3 dimensions, it's the same formulas. I just add a z. And if I'm in 4 dimensions, just add a whatever variable. And you can just keep on going forever and ever. And it's the same formulas. You're just adding one extra piece of information. So let's do an example. We're going to find the distance and midpoint for points A and B. Notice, do I have a symbol for point? No, I do not have a symbol for point. By using a capital letter, it's understood that we're talking about a point. I don't need to do one of these deals. Point A. I don't need to do that. Capital A tells me I'm talking about a point. Whenever you list one letter, it's 1 point. How many points do you need to name a line?
2.
How many points do you need to name a ray?
2.
How many points do you need to name a segment?
2.
Right. How many points for a plane?
3.
Should you use 3 points to name a line?
No.
No. 2. All right. So anyways, I digress. All right. So first example, point A. Let's do -5, 1. In point B, let's do 6, 4. We'll do another example. I'll just use the same space. All right, so I'm going to find the distance and the midpoint. I'm going to do both of those with those points. Notice, how do I know I'm in 2 dimensions? I have 2 pieces of information. 2 pieces of information. Versus over here, 1 piece, 1 piece, so 1 dimension. All right, so what does 2 dimensions look like? You know this thing that you used lots last year? 2 dimensions. Okay?
It's not that bad.
So, all right, here we go. Distance. Going to do square root. And make sure your calculators are handy because I made this up, so it probably doesn't come up very good. So -5 minus 6. We'll square that. Plus 1 minus 4. We'll square that. Now we do everything inside the parentheses. So I do -5 minus 6. Now you should know that's -11, but if you don't, use your calculator to help you. Plus 1 minus 4 is -3. Now in this case, I can't just cancel out the squares. That's not going to work. It works in the first formula because I'm not adding anything extra. But I have 2 pieces here, so I'm going to have to actually do them. So 11 squared is 121. Again, if you don't know that, calculator helps you. -3 squared, that's 9. And then we'll do square root of 130. Now, last year, you are correct. You would prime factorize and then you would get an exact answer. For now, we can just put that in our calculator and round. We'll get to that extra stuff later, but I'm glad that someone remembered that step. So we'll put square root 130 in our calculator. We will be careful to read whatever directions we have to round. For now, we'll just do to the nearest 10th. So, to the nearest 10th, square root of 130.
11.4.
11.4 is what I heard. I don't have a calculator, so I don't know if that's right, but we'll go with it.
Mr. Peg, how do you like, I got just square root.
Okay, so yeah, those of you who are on especially the more expensive Casio calculator, when you put that in, you put in your square root, and you put in 130, and probably your Casio is going to give you the exact answer. What did it pop out?
Square root 130.
So it popped this back out. It'll simplify it for you exactly, so you can use, when we get to that part, you can use it. So the button you're going to look for is F arrow D. And what that's going to do is it's going to switch between fractional exact form to decimal form. So you put in your square root 130, you press execute, it gives you square root 130, then you press that F arrow D key, and it'll switch it to a decimal.
Mine just gave me 11.401.
Okay, that's fine. Then you don't need to worry about what I just said. Okay, so this is what we want. Okay, so that's distance. Let's do midpoint. Midpoint. So we're see, notice with distance we subtract our things, and with midpoint we add them. Midpoint is just an average. Just an average. Don't make it any more complicated. All right, so I'm going to add my 2 points. So -5 plus 6. Remember, this is x comma y, So we do -5 plus 6 divided by 2, and 1 plus 4 divided by 2.
We get 1/2. We get half.
55 seconds.
And we can leave it like that if we want. If not, we can change that to decimal form.
I'm leaving it like that.
2.5.
So either of those answers is correct for that.
Mr. Kane, is this all that's to this?
Yes, we will do one more. Yep, that's fine. That's all we need to do. All right, so we'll do one more example. So point A, let's say, is 2, -7. In point B, let's say that's 8, -1. Okay, anyways, we're going to find distance and midpoint. Write your formulas every time you use them. That way you memorize them. That way next year when you're in Algebra 2 or further in pre-calc and you're assumed to know the formulas, that's an actual right assumption. So we don't want to forget these. So we write them every single time. Because if you don't write them, you're going to forget the little details.
That's probably going to become like the instructions.
Like you just did.
Like I just did. Thank you. Leave it to Daniel to point out everyone else's faults.
No problem, guys.
Leave it to everyone else to point out.
Yeah. We invented
Yeah, we outnumber you.
Yeah.
Okay, so we do distance is square root. Don't mix up your x's and y's. So I'm going to do 2 minus 8. I just do it in the order they appear. That's fine. Your book might give you the formulas where they put the 2 and 1 in different order. It doesn't matter. Just be consistent. So -7 minus -1 becomes +1, right? So we get -6 squared plus 6 squared. When we put this in our calculator, just by the way, if you put it in your calculator like this, your calculator is going to say -36. This is in parentheses, so that makes a difference. -6 squared, we want it in parentheses, is +36.
Same number is supposed to be -6.
Okay, thank you. So 36 plus 36 in the end is going to be square root 72. Your calculator might pop out the exact answer of 6 root 2,
8.5.
which is about
8.5.
8.5.
Hey, Kane, can you go back to the lesson?
I will in a moment. Let's finish up this midpoint. Midpoint. So what will I put in my first fraction?
You'll put 2 and 8.
2 plus 8 divided by 2, and -7 plus -1 divided by 2. Now you could put that on your calculator, but plus minus is just minus. So we get 10 over 2 and -8 over 2. Those reduce. So we get 5, 4. Notice this is an ordered pair. Ordered pairs need to be in parentheses. This is an actual length. This is a point on a coordinate plane.
So if you don't put the parentheses, it's wrong.
Yes. It would be wrong if you do not have the parentheses.
Okay.
All right, so any questions on how to find distance in midpoint?
Going once.
Okay, and someone asked for me to go back a slide, so there.
Are we done with notes?
Okay, yes, we are done with notes. Quickly get a whiteboard and marker.